Okay, so this is the last part of your experiment. Now, earlier we will have problem with our power supply because I only have one power supply, which is plus 10 volts, 10.3 volts. Now I have replaced my power supply with a back-to-back battery here. This battery is special, 12 volts each. Small battery, but it is 12 volts. So I collected my ground in the middle. So I will have here a positive 12 volts, and the other side that is negative 12 volts, because I am measuring with respect to the ground. So this one is the middle. So the one in the middle is in the ground. Okay. So if I'm going to measure now from ground to the here, as you will see, it will measure here. It will measure negative 11.9, 11.8 volts. Okay, on the other side, I'm going to measure positive 10.3 volts. Okay, so there's a little bit of a drop, but still I have two voltage supply now, positive 12 volts and negative 12 volts. Just, you know, that is what is required of a differential amplifier. Alright, so I supplied now my differential amplifier with the negative 12 volts here, pin number 4, and the positive 12 volts I connected it to pin number 7. You just check now. Okay, so pin number 7. Okay, so here I am going to measure now my Wheatstone bridge. Of course, this Wheatstone bridge now is connected to 12 volts. 12 volts only, because it's ground plus 10.8. So it is basically connected to 12 volts. Okay, so I'm going to measure now my offset voltage here. Okay, so here, see? So the offset voltage, or if I adjust this one here, you will see that it is increasing. Why? Because the bridge is becoming unbalanced. Okay? When the bridge is unbalanced, of course, there will be the offset voltage. So I'm going to balance now the bridge by adjusting this potentiometer. Okay, to make the bridge balance. Okay, so there you go. I will put it here on 20 so that it will be, the sensitivity will be more. There, almost 0. So that will do. Okay, that will do. There, almost 0, right? So the offset voltage will be 0. So if I'm going to measure now my voltage from ground to 0.1 with respect to the ground. So look here, I'm going to measure now your voltage at point D with respect to the ground. That is a 4.8, 4.9. So I'm going to measure on the other side. I'm going to measure with respect to the ground. So it's the same, 4.8. So it's already balanced because of the voltage E and voltage D are the same. Therefore, the bridge is balanced. Now since point D and point C is connected to my input 2 and 3 here, inverting and non-inverting input of my amplifier. Therefore, that now becomes our differential amplifier. Okay, all the resistors here are the same. They have a value of 1K, so therefore the gain is unity 1. Okay, so I'm going to measure now the output voltage here. There, so there, the output of your amplifier is 0. Why? Because it is balanced. Okay, the voltage that you're here, if you are going to see, you're going to look now the voltage at point D. This one is 4.4. The voltage here is the same, 4.4. Therefore, the output voltage will be 0. Okay. The output voltage will be 0. Now look, if I am supposing, okay, our Rx changes now, because remember this is our sensor. Supposing this is a strain gauge, so if you apply pressure, weight or force or a displacement, the resistance of our strain gauge will change. So therefore there is now an offset voltage. So see there. So see there. There is now your offset voltage. Now there you go. There you go. Now this time your offset voltage is measured by your operational amplifier 741. No longer by the multimeter. So we are measuring the output of our amplifier by our multimeter. Okay? So the bridge now becomes unbalanced. The bridge now becomes unbalanced. Okay? And it is measured or collected by your operational amplifier 741. The output of which is measured from the ground to the pin number 6 of your operational amplifier. So this one acts as your differential amplifier. This is your pin or your point D, and this is your point C. Your point C is, you will see it is inputted into point 2 here, point 2 or pin 2 of your non-inverting amplifier. Your non-inverting amplifier has your feedback resistor is connected there, your feedback resistor 1K, and your input resistor are in 1. Now your point D is now connected to your pin number 3 or your non-inverting input of your amplifier. Okay, this is your R2 and this is your R1, your input resistance for your pin number 2. So they all have the same value. They all have the same value of 1K. Therefore, there was an offset voltage of the gain will be unity. Therefore, the offset voltage is just multiplied by 1. So this is different from earlier setup where I wasn't able to collect or get the output voltage because of the input of my operational amplifier is 1 volt, single voltage supply only, which is 10 volts only. I have no negative. So your differential amplifier will not work properly if it is connected only to the ground. Okay, ground and 10 volts. It will not work. Okay, so that's why I changed my supply with this 12 volts power supply, where there's a center tap which is connected to the ground. So this is my positive 12 volts and this is my negative 12 volts. Now I could get now my output there, 12 volts here. If you will see, what's good. If your say for example your strain gauge experience compression, remember, if your strain gauge experiences tension, the resistance will change, will increase. But if your strain gauge experiences compression, therefore the resistance will decrease. That's why here you will see there that there is a negative feedback. Now here, see there, -1, meaning the resistance of your strain gauge fall below 1000. Earlier there's an increase in the resistance. There's an increase in resistance. That's why you have a positive here. So here I rotated my potentiometer to the left, meaning less resistance. Now if it is less resistance, meaning it is less than 1000. If this is less than 1000, say for example this is 800, this is 1000, 1000, 1000. Therefore the voltage at point C is greater than the voltage at point D. So therefore you will get now negative voltage. But see, if I am going to Again, I'm going to balance now my bridge circuit. I'm going to balance my bridge circuit. There. Now there, almost balanced, no? 0.0, 0.03. Meaning the voltage here at point C is the same as the voltage here. So if this is 1,000, 1,000, 1,000, your Rx will be approximately 1,000 also. Now, again, if I increase the resistance of Rx, why will it increase? Because I applied pressure, force, or weight, or displacement positively. Meaning, positive means I increase the resistance. So the resistance increased. There, you will see that the voltage now changed positive to the positive. There. I can increase it until 2. Actually, up to 2. Depends now on my there. So what we are proving here is that we are using now our amplifier 741 as a differential amplifier by measuring the voltage difference between D and C. Your D is your positive. Remember my lecture, positive, and this is my negative. Okay, so meaning if it is positive there, so this is a higher resistance than the other 3 fixed resistor. Okay. So I need to press this one because it is loose. I have no good battery holder. That's why I am holding this. So we are done with this second part. The third part is I hope I can finish it before we start. I am going to adjust this one now. I can amplify this one now. I will try to amplify this output voltage using another 741 in order to calibrate now my measurement into the output. Why is that? Why is that? Because I want to, supposing I apply here 8 psi. 8 psi. So I want to see here in my voltmeter 8 psi. But I only see 1.57. So it's not a good representation of my measurement. Okay? What I will do now is I'm going to try to increase this voltage using another 741 configured as a non-inverting amplifier so that I can adjust it to 8 volts. So if I have here 8 volts now as my output, therefore it is a good representation of my physical measurement, which is 8 psi. 8 psi, 8 volts. I told you before, I'm just going to wrap out the volts there, and I'm going to change it to psi. That's what I'm going to try next. Okay? So take hold of this experiment, and you're going to write this one down. Okay, so hopefully this one will work finally. Now the supply, we have here now our amplifier now. I have here another potentiometer so that this is my variable resistor, so that I can adjust the gain. So that I can adjust the gain of the non-inverting amplifier. So here is my Whitson bridge. So I have my point C and D. So it is connected to my differential amplifier. The output of my differential amplifier is this, pin 6. Okay, then I input it to my pin 3 here, non-inverting input of my non-inverting amplifier. Now, this is 1K, my Rin 1K, and my RF is variable resistor 10K. So I can adjust my gain up to 10 times, because this is up to 11 times actually, because this is non-inverting amplifier. So 1 divided by 10, 10 divided by 1, 10 plus 1, that is 11. So a maximum of 10 times 11. Okay, so this is my variable resistor. Okay, Now, my feedback, as you can see here, my feedback 6, pin 6 here, I connected to my variable resistor and go back to my pin number 2. Then pin number 2 connected to my R input. Okay, so my input coming from my differential amplifier is fed. If you are going to check, it is fed now to my pin number 3. Okay, my amplifier is supplied with positive 10 volts and my negative 12 volts, positive supposedly 10 volts, but the voltage is less. Okay, so I'm going to measure now my output voltage. So I'm going to measure first the output of my bridge. So this is my bridge, right? So the output of my bridge is from the differential amplifier. I'm going to connect this one now here. There. So 1.8. Supposing again, I'm going to adjust now my Wheatstone bridge. I applied now a pressure on my Wheatstone bridge. Applied, say for example, 8 psi. 8 psi. So with an 8 psi, I have the offset voltage becomes 2. Or let's just make it rubbish, any rubbish number. So 1.88. So 1.88 is not a representation of 8. Well, let's make it so because it is so then 1.7. Okay, 1.7 is not a representation of 8 psi. Can you imagine that one? I put here, I applied pressure on my strain gauge with an 8 psi. So I want, if I have an instrument, I want a reading of 8 psi. 8, right? An 8. But it is reading from my first amplifier, it is only 1.7. Right? 1.7. So what I will do now is to amplify that 1.7 so that it will become 8. A value of 8. So I'm going to input now my output here to my non-inverting amplifier. Okay, I put input 3 and I'm going to measure now my output. So here, so I will adjust now my gain here. So there. So now I apply the pressure here. I apply the pressure here of 8 psi. Now I am reading now 8. Is that meaningful? Is that helpful? Yes, of course. I applied here 8. I read 8. Right? Because I'm going, without the amplifier, I will only read 1.7. So 1.7 is not a good representation of 8 psi. So what I will do now is I'm going to use my amplifier here so that it will, I amplify it so that it will read now 8 volts there. 8 volts, yes. So it's a good representation of my, so that's it. So we have finished the whole system from Wheatstone bridge, where it changed wherein it changed our applied force into change in resistance. Then I convert it to change in voltage. Then I connect it through my differential amplifier. Then I amplify it so that the reading will be meaningful. Meaningful meaning because I applied here a force of 8 psi. I want a reading of 8 by adjusting it. Okay, so that's it. So supposing supposing I applied here a force of 5 kg, say for example 5 kilogram. Okay, so 5 kilogram. So there, right, 5 kilogram. There, 5 kilogram weight here. I will see there 5 kilogram. Because if I am going to measure only up to the Wheatstone bridge, it will only give me a measurement of 1.6 after the Wheatstone bridge. So yes, the signal is converted into a parameter, but not meaningful. So because the output of my Wheatstone bridge is only 1.6 volts. So I have to amplify it into a value that it will become meaningful. So I applied here 5 kilogram. I want to see a reading of 5 kilogram. So by adjusting now your differential amplifier there, it will give me a 5 kilogram output. Okay, so I hope you will be able to document this experiment and submit the report next week. Okay? With that, thank you very much and see you then. See you later.